Welcome back. Today we're going to go into set theory. So let's throw it all into this Excel sheet. We're going to be using these sets mainly, so I've rewritten them here. This symbol is for a set, and a set is a collection of elements that, and we're going to use again these three. And note that order does not matter and duplicates are irrelevant. So we don't have to go 3, 5, 6. That doesn't matter. And if we have duplicates, that also is fine. It just equals the set without them. So then what's within a set, those are the members, elements, or objects. And the definition is distinct objects, anything. I mean, it can be the color green, that make up a set. Note that if an object is another set, then that set, not its contents, is the object. So 3, not the same thing as set 3. And this kind of goes into this duplicates piece. If we have set D and it's 1, 2, element 2, or sorry, 1, 2, set 2, green, set 5, 4, and 4, it has elements 1, 2, set 2, green, set 5, 4, and 4. 2 and set 2, that's not a duplicate. They are separate things entirely. Okay, then these two mean that that one of these is an element of a set. So 5, we see that it is part of set A. And then for X, it's not an element of, so 1 is not an element of A. We don't have a 1 in A. We also have this symbol. You should be familiar with this one, but they're using it to mean empty set. A is not empty, it has 5 objects. Next we have such that, so B is the set of X such that X is an element of A, but X is less than 21 and X is not equal to 5. So is that true? So less than 20... Well, actually, it should be less than 25. So if it's less than 25, then yes, that is true. Because that just makes it 5, 3, 17, 21 that are available to us. And then if we have X is not equal to 5, we have set B. So that works out. Next we have intersection. So objects that belong to set A and set B. So that would be 3, 17, 21. That is where they coincide. For a union, that is the objects that belong to set A or set B. So you're basically taking out the duplicates and giving me all the unique. So between the two of them, there is 5 objects. So since B is completely within A, let's say that we did the union between A, B, and C. If we did that, right, so if we did, or actually we could just do A union C, that would get the same thing done. If we did A union C, that would give us the set of 5, 25, 3, 17, 21, and 68. So C has 68, A does not. That's fine. 3 was a duplicate, but remember, duplicates don't matter. They mean the same thing. So that works out. Moving on then, we have B is a subset of A. So yeah, B is included within A. That's all it means. And a subset can actually be the same set. That would be fine. So if A was 3, 17, 21, this would still be true. This is where that changes. So a proper subset means that they cannot be equal. So B is a subset of A because all of B is within A, but A and B are not equal. C is not a subset of B because all of the values which C has are not within B. A is a superset of B. Let's see if that is true. A is a superset of B. Set A includes B. So this is just this rewritten, right? A superset and a subset. We're using the same symbol, but we're just putting it in a different order. And that also applies to these two as well. So A, proper superset, or sorry, this was, yeah. So A is a superset of B. A is also a proper superset of B because A does not equal B. And then, just like with those, if C is not a subset of B, then A is not a superset of C. Because this, again, it's the same symbol. We're just turning it around and then also reversing the letters. So the same